Welcome to the FOQUS usage guide, and for this video we are going to show how to perform optimization under uncertainty, or OUU, in FOQUS. And for this video we are using the same example file as the one that we used previously in our optimization video, and the link for this video is shown in the description below. So the first thing we're going to do is, after we already set up the node and everything, we go to our OUU tab here to perform the optimization under uncertainty, and we're going to select the entire flow sheet to perform our optimization under uncertainty. And in this case we're gonna keep A fixed, but we're going to have B become our uncertain parameter. So as you can see, we have different types of uncertain parameters. So where we can have a discrete uncertain parameter where they assume discrete values, or a continuous uncertain parameter where we assume that value is continuous from its lower bound to its upper bound. And in this case we're going to select continuous, and we're going to assume that this variable is uniformly distributed. And then we're going to set the values of x and y as our decision variables. And as you can see, once again, we can have continuous or discrete. Discrete meaning that they have to be integers and can only assume specific values within the bound, or continuous, which means that the variable is continuous from its upper to lower bound. So in this case we're going to select x and y to be continuous decision variables, and as you can see, these numbers are recorded. So we have one fixed variable, two decision variables, and one uncertain parameter. And notice there's also another type of variable, which is the recourse variable. In this case, the recourse variable is in the case where we perform two-stage stochastic programming, where we have our design variables are the values of z1, while the recourse variable, or the second stage decision variable, is the value of z2. But in this case we're going to stick with z1, and this setting is fine. So we're going to optimize our expected value of our objective function. And now we go to our output. So in this case we have our objective function, which is the value of z. So we go to our UQ setup. So we're going to assume Latin hypercube for our uncertain parameter, which is our variable b here, and we're going to select 5 samples for this example, generate using the Latin hypercube sampling method, and we go to our launch in progress and we click run OUU. So this screen always shows up whenever we run optimization under uncertainty using the OUU tab, and this table shows the iteration number that we have, as well as the best value of our objective function, as well as the values of our decision variables. As you can see, the optimization under uncertainty is successful, so we click OK. And so the best value for our objective function is -50, and decision variables ends up becoming -10 for x and 4 for y. And we can always go to our flow sheet and click on the flow sheet table. And as you can see, the values that we gained from performing optimization under uncertainty in this case is listed under listener for the set name. So what we're going to do is going to go to menu, go to export, and then copy data to clipboard. And we're going to go to Microsoft Excel and paste this information. So we go to the very bottom under listener, and we delete everything else. So we're going to select this and delete the row. And I'm going to use freeze pane, and likewise as in the previous video, I'm going to make these wider. And in this case, as you can see, we have the value of A, which is fixed at 5, and for the value of B, it's being varied, so it goes from -10 to 10. So in this case we have 5 different samples, so they're shown here. So -5, 0, 5, 10, and -10, and then these are the values of x and y, and then these are the values of z, our objective function. What we need to do is check the value of our objective function, and we need to check the expected value. And because we have over 200, so I think it's best that we write a code in Excel to determine what the expected value of z is at each iteration. So in this case, this is our first iteration, then this is our second iteration, and this is our third iteration, and so on. However, the instructions for writing the XSL code will be left for the user, and we will not cover it in this video. So this concludes this portion for forming optimization under uncertainty using FOQUS, and thank you for watching.